Okay, guys, we're going to look at 5.2, and we're going to start off with the multiplication of integers, which, as we've already talked about, is positive or negative whole numbers. Okay, so when we talked about multiplication and division last time, there is a method that I haven't really gone into, which is the pattern model, and it's very useful whenever students are first learning. But when you're first learning how to add whole numbers, some students will actually use it as kind of a crutch, which is why I don't recommend stressing it very often. But with negative numbers, it can really illustrate a pattern that is harder for students to grasp otherwise. So what I've got here is 3 to negative 3 being multiplied by both negative 2 and by positive 2. By the way, I'm doing this by hand with a different camera than usual, so and different recording program than usual. So it's going to be a little bit harder for me to do stuff like pause my video or adjust without you guys seeing it. And so just bear with me, but this is a faster way for me to write these things, so hopefully the video will be shorter. Anyway, so 3 times negative 2, we're going to write that as, or well, actually, let's do the positive first, okay? So 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2, and then 0 times 2 is 0. So we know these because of our work in Chapter 3, working on basic multiplication with whole numbers and natural numbers. So if you look at what we have here, we have a pattern that starts from 6. So we have it's going down 2, going down 2, going down 2, and it's decreasing because we're decreasing here, okay? And then multiplying that decrease by 2. So that means that our pattern should hold because the pattern of numbers should hold. So going down from 6 to 4, 4 to 2, 2 to 0, we should then move on to negative 2, negative 4, negative 6. We are still decreasing, so 2 less. I guess we should mark that off that this is less. That's supposed to be. Okay, so that's going to continue. Okay, so our 2 less should happen each time. So we now have that when we multiply a positive times a negative, we're going to get a negative number. Okay, so we have a positive times a positive, still going to get us a positive. And then a positive times a negative, we get a negative. Whoops, not negative 1, just a negative. Oh, I hate when my arm is all zoomed in like that. And now that I've mentioned it, somebody's going to notice it. Anyway, so then you have the same pattern here. And so like I said, we know a positive times a negative is a negative. Well, we're just, kind of going to go on a little bit of faith here that a negative times a positive is a negative. And for anybody who's confused about why that is true, I want you to look up the commutative property of multiplication. Okay? Anyway, so 3 times negative 2, that gets me negative 6. 2 times negative 2 is negative 4. So our pattern, hopefully you're noticing, is actually increasing. So from 0, we're going to increase to 2. And I'm not even looking at the numbers that are being multiplied. But when I pay attention to what I've got being multiplied here, I suddenly have a negative times a negative that gives me a positive. And I'm still just holding to this pattern, but that shows me in a different way this relationship, because this double negative is very confusing for students to get the negative times a negative. And we've already hit on that when we talked about subtracting double negatives, but the idea is still happening here, the negative times a negative being a positive. So this is demonstrating a pretty important property. This right here. Okay, So that is the pattern model, and it does get you to see all 4 operations here. I would recommend probably writing this column on the other side. I started off with what was prompted and then realized, no, I want to include this as well. So sorry about that if that is confusing. Okay, sorry, I'm just trying to include a little more here. Okay. Next model we're going to look at is the chip, which is basically the same thing as the charged field model. And I am sorry that there's a shadow here. Let me see if I can move the light just a little bit. Don't know if I can. Oh, the cable is not working with me. Let's see. Don't fall. Oh, that somewhat works. Still a shadow. Sorry. And now I can't see my screen anyway. I am so sorry about that. Oh god, I think I'm gonna have to restart my video. This is a lot. Hopefully you guys are okay. Maybe whenever I can do some post-production stuff, we'll see. I'm sorry about that loud noise. Okay, so the chip charged field model is, again, basically the same thing, and it starts off kind of like the model that we had before when we were doing addition and subtraction, where you start off with like a playing field. And we're going to talk about the problem 3. We're going to start off with a positive times a positive first, and then we'll move from there. So that means this is a positive. That means we're going to add 3 groups of 2 positives. I should actually write out the word positives. So what you have here is this first, based on that first sign, then you have a number. Groups is always the same, groups of, and then you have a number, and this is based on that second sign. Okay, so those will change based on the problem, and you'll see that later. So we're adding 3 groups of 2 positives, and this time around, I'm just going to make my blue highlighter. No, let's do my markers. I have a green marker and a red marker. So we're going to add 3 groups, and so I'm going to put in 3 groups here. 1, 2, 3 of 2 positives. Oh, you know what? They're positives, so I'm going to use green. 1. That's 1 group of 2. 2 groups of 2. And 3 groups of 2. No, maybe if I turn this light over a little bit, it can keep my shadow from being so bad. I think that helps. Okay, so we have 3 groups of 2 positives. We have completed these directions, and so we started off with 0. This is where we started off with 0, and then we moved to 6. And so that means that 3 times 2 equals 6. Hopefully that made sense. And as we move on through other examples, it will get clear. So the next thing I want to do is I want to make my second digit a negative. So let's just go with 3 times negative 2. Well, simple numbers, the same thing basically. And so again, we want to start with our empty field of 0. Okay. And I'm going to follow the directions that I have here. So if you'll remember, I had, my red pen, a box, or sorry, blank, box, groups of, box, blank. Okay, so the first number is still positive, so we're going to be adding 3 groups of 2 negatives. So I'm adding them in. I'm just going to put in the 3 groups already. You don't need to put in the 3 groups normally. I really want to illustrate that we're following those instructions. There's 3 groups and it's 2 negatives. So I'm going to put in negatives in each group. So 1 group of 2 negatives, 2 groups of 2 negatives, 3 groups of 2 negatives. So it was 0, and then I added 3 groups of 2 negatives to get -6 total. Give you guys a second to get that down. If you need to pause the video, I recommend doing that. So I'll give you 3 seconds, and then I'm going to turn my page. All right, I'm turning my page now. Give me a sec. Sorry. Oh, my desk is scratched up. Slide forward. Okay. So we've done the first number positive, or both numbers positive, first positive. So let's just see. We've done positive, 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 negative. Now let's do negative, positive. We can still do that. Okay. So we'll go with -3 times a +2. So a blank number groups of number, and it's that second number is positives. So in this case, because my first number is negative, I'm going to be removing 3 groups of 2 positives. So I want to start off with 0, and I want to take away, but I don't have anything that I can take away in here. So just like when you are subtracting a negative amount, I need to still have 0, but I need to put in 3 groups to take away. Okay, so if I'm going to be removing 3 groups, I need 3 groups in there. So, but I still need to equal 0. So I'm actually going to see, let's see, 1, 2, 3. And I'm going to be taking out 3 groups of 2 positives, which means, let's see, so I'm going to put 2 positives in each group. 1, 2 groups, 3 groups, but that's not 0. That is too many. I haven't been able to remove anything yet, so I need to put some stuff in so that way it's still balanced, it's still 0, before I can follow these instructions, just like before. So 1, 2, 3. So if I have 3 groups of positives, I need 3 groups of negatives. Otherwise, it's not 0, and then I cannot follow these instructions. So I start off with 0, and I still have 0, but now I have what I need to be able to remove 3 groups. So here's a group of positives. I'm going to take it out, of 2 positives. I'm going to take all 3 of these groups out, so that way I can follow those instructions. And so what I'm left with is that there. So I'm just going to draw those in. So 1, 2, 3. Markers over here, and I kept it. Oh, sorry. 1 group of 2 negatives. There we go. So that matches what is left behind. So I have -6 is my answer. It's another way to illustrate this relationship. Okay. Oh, I'm saying that relationship equals a positive, equals a negative, equals a negative. I should just put parentheses around all of my symbols. Why don't only the negatives get it, or only the second one? Anyway, so that is 3 out of my 4 relationships. I need 1 more. I need to do the negative, negative. And luckily, this helps us out quite a bit. That's the same approach we're going to want to take. So I'm going to give you guys the problem -3 times -2. And if I were doing this in my digital note-taking app or program, I would pause it at this point and then just kind of unfreeze after showing the answer. But In this case, because I'm doing it by hand, I want you guys to just, you pause the video and then take a look and then do your work on this one, see how you could represent it using this chip model, and then and then you can unpause and take a look at what I've got while I'm working through it. So I'll give you like 3 seconds to pause and then unpause. Okay, so we start off with 0. And we want to, I should write out my instructions here. So I'm going to remove, since that's my first symbol, 3 groups of 2 negatives. Ran out of space on the paper, sorry. So for me to be able to remove 3 groups, let me do like a little bubble around this so it's clear. For me to be able to remove 3 groups, I need to have 3 groups. But I'm still starting off at 0. So I'm going to put in 1, 2, 3 groups of 2 negatives. And then I have to put in 3 groups of 2 positives, so that way it's still 0. Okay, so what I have here, because those all cancel each other out, is 0, and now I have everything I need to follow these instructions. So I'm going to take out 3 groups of 2 negatives. So that's 1 group of 2 negatives, 2 groups of 2 negatives, 3 groups of 2 negatives. So all of those leave, and so I am now left with, sorry, trying to find my marker. This image here, and that means I now have an answer of 6. So this is a clear proof, or clear visual. I don't know that I would say that this is a proof, but it's a clear visual that -3 times -2 equals 6. And I don't know of any other better visual to show students what this actually is talking about. Oh, sorry, my mouse is covered by the light. Oh no, I moved my notes. Okay. Now, there is one other model that can seem a little confusing just to describe, so bear with me. We're going to look at the number line model. And for this one to work, you need to understand or think about a hiker, like I told you guys before, or just me, in the middle of a space, and your textbook talks about east and west. We'll do that just so that way we're sticking with the convention that they have. Going to the left is west and going to the right is east. And so we will say that going to the left is negative. These are negative values, and going to the right are positive values. And then, so we're talking about my movement or a hiker's movement in time, okay? So for time, of course, the future is a positive number or positive time. And if we're talking about the past, then we're going into negative time, okay? So there's some scenarios that they give that I think really do illustrate fairly well this whole positive times a positive, I'm sorry, negative times a negative equals a positive thing. So we'll do the same thing as we did for the chip model, where we start off with positive, positive. So if we talk about 3 times 4. So this situation would be that you are moving 3 east for 4 hours into the future. Okay, so if you go 3 miles per hour, I should put mph there, miles per hour for 4 hours. So if you go 3 miles per hour for 4 hours to the east, and we know it's east because it's positive, so that means you're going 3 here for 1 hour. 3 more for another hour. 3 more for another hour, and then for 1 more hour, so this is 4 hours total, you move 3. I just realized I'm working on a number line and I didn't use the number line as a visual. I'm so sorry about that. Let me try and be more distinct here. So there's 0 is that line, and then 1, 2, 3. So this should actually be my first line. Oh, that's going to be confusing. I wish I had my white out in front of me. And then 1, 2, 3. And then 1, 2, 3. I shouldn't have done this. I'm so sorry. I'll color it to make it more of a visual in just a second. So there we go. So if I really wanted this to be accurate. So here is 0. There's the first hour, second hour, third hour, fourth hour. Hopefully that is clearer now. So hour 1, hour 2, hour 3, hour 4. And so you end up at positive 12. So that means that you end up 12 miles east. And that's why it's positive 12. So let's say that you go for 3 miles per hour to the west. I'm sorry. You were going for 3 miles per hour since 4 hours ago. So 4 hours ago. Okay, so that means, and you're still going east. So you're going 3 east since 4 hours ago. So where were you 4 hours ago? I apologize, guys. Sometimes I'm not great at wording this stuff. So you were going east, but you were 4 hours back. How do I say this? You know what? Let me think. Yeah, okay. So if you're at 0 now, and 4 hours ago you started walking 3 miles per hour east, that means you were walking this way. But we're trying to talk about where you started, so we're gonna go this way. That's what's gonna happen. I'm so sorry about that. Let me repeat that. So you're at 0 now, okay? And because we're starting at 0 for every single one of these, always at 0. So start at 0. And you're starting at 0, okay? Or not starting, it's like now. You are now at 0. And then you go from 0, 12 miles. Here, you're at 0, but 4 hours ago, you were someplace else. So we're like, well, where were you 4 hours ago? Okay? So if you're at 0 and you've been walking this way, well, then that means that you came from this way. So that means you went, 3 miles per hour. So there's 1 hour, 2 hours, 3 hours, 4 hours. And I was accurate this time. So that way it's very clear. So that means that 4 hours ago you were at negative 12, or you were 12 miles west. And this is just, again, another way to show this kind of idea. So I wanted to give you guys the number line model as well. All right, so this next one, we have that you're now at 0. That's where you're at right now. Okay, and you're going to move west 3 miles per hour. And so we want to know, and you're going to go for 4 hours. So you're going 3 west for 4 hours. And so we want to know where you're going to end up at. Okay, so you're at 0, and you're going to go 3 miles per hour west for 4 hours. So you will end up this way. You'll end up at negative 12, or 12 miles west. It's weird, W. Sorry. I'm trying to write while looking at the screen. So, and we're going to translate all this to positive, negative in just a minute, okay? And then the last one is that you're now at 0 again, or you're at 0, just right now, and you were moving west 3 miles per hour. And so where were you 4 hours ago? So you're going 3 west 4 hours ago. Where were you? So let's figure this out. You were at 0 and you were moving west. So you were moving this way, but you ended up here, which means that you came from this direction. So you were moving west and you ended up here. So let's count back. So you're going 3 miles for an hour, 3 miles for an hour, 3 miles for an hour, and 3 miles for 4 hours. So that means you were at 12 miles east. So again, let's translate all this into positives and negatives. So you were 3 east, you're at 3 positive, and you're going 4 hours into the future. You will end up at a positive 12. You were going 3 east, so it's a positive 3. And you were talking about where were you 4 hours ago, so that's negative 4. And that's when you end up at 12 miles west, or negative 12. Here, you were going 3 west, which means that you were going negative 3, and you're going 4 hours into the future. So you end up at negative 12, or 12 miles west. And then here, you were at, so you were going 3 west, or negative 3, because west is negative. And we were talking about where were you in the past. So where were you 4 hours ago? And that means you were at 12 east. Okay, so I want you guys to consider that. You know, I could possibly ask questions about number lines and moving east and west, just because it is a great way to explain this for people who like to think linearly. Now I'm looking through the rest of the notes for this section, and I hate to just lump division in with all of this stuff, but division is, you know, it's an extension of multiplication. It works the same way. So let's just try doing, you know, I don't think that we don't even do a chip model for division. Let me consider really quickly. Yeah, I guess I can try doing one with you guys, but it's just another way to do a visual, which I think with multiplication we've already got some really great strong ones. So we'll see if this is beneficial to any of you guys. So if we're talking about division. So we start off with 0. And let's do 12 divided by negative 4 and see what happens. So I have a positive 12, so I'm going to put positive 12 in there. Hopefully that is clear to you guys. It's positive green. And I'm going to break that up into 4 groups that I remove. Yeah, let's see. So I'm going to break that up into 4 groups. Let's see, so that I will then, let's see, how would you show the negative portion of that? See, if I'm saying that I'm removing those, that can sort of show. No, the remove comes with the first part. So because that's a positive, I'm adding it in essentially. So add 12, and then you break it up into 4 groups and into 4 negatives. How do you show the negative in here? I think this is why we don't do the chip model, because the only thing you could really do to show the negative is to flip that sign, and that doesn't teach you anything. That's just following a step. So if anyone is interested or has any ideas, let me know. If you can come up with a way to show that you are dividing by a negative value without just flipping the sign, or if you have a justification on why the sign can flip, send me an email or make a comment to tell me that. So this section also includes order of operations. I think that that is something that you guys have had some practice with, and so I'm not going to hit on that at all in this video. It's already fairly long. I believe that you guys will be just fine. If you do have questions, always feel free to reach out about it, okay? Hopefully this has been helpful, and we'll talk about this more in class.